Question number 1. Sketch the graph of this is a fourth order polynomial, okay? 4x cubed plus 10. So when I ask you to sketch the graph of this function, the idea is you have to think about finding extrema. Extrema by what I mean is minimum, maximum, and inflection point. Okay? So this is like a rough idea what you should do, all the steps. Okay? So extrema will help you to find minimums if there exist, minimum, max, or inflection point. Minimum points, maximum point, or inflection point. Okay? To do that, you have to set the derivative equal to 0. That's your first step. Okay? And we can talk about second derivative later and find out where the function concave up and concave down. Okay? So I will write down all the steps, you should follow. So you don't need to always go through the steps, but the idea is you have to take the first and second derivative. Okay? First, part A, highlight here. Identify where the extrema occurs of fx. Identify the extrema. So exactly you need to take the derivative. Okay, so take the derivative first, and you get 4x cubed minus 12. It's 4x cubed minus 12 x what? Square. And that's no any other terms because to take the derivative of 10 is 0. Okay? Right. So you get the derivative and you have to set it equal to 0 to think about where the extrema occurs. Okay? Before I set it equal to 0, I'm going to factor my derivative, first derivative. To do that, because you need to, because the next step probably you have to understand where the function increase and decrease. You not only need extrema, but also you need the sign, the plus minus of your first derivative, because it gives you, whether the original function increase or decrease in a given interval. Okay, so you got those values, and so maybe I make a line. Okay, so you can make a table if you want, but the important point. One of the important point is x equal 0 and the other one is x equal 3. Everybody agree? Okay? Good. So at this point x equals 0 and x equals 3 you may have minimum, maximum or inflection point. Okay? Now you have to think about what happened less than 0. So I'm going to talk about the derivative, okay? F dash x. Tell me what happened if you take any number less than 0. What happened to your derivative? Anybody? Just plug like -1. Whatever number below that, okay? So I'm talking about -∞ to 0 interval. So if you plug -1, what happened here? This become negative. This is always positive. So the derivative is negative. Agree? So I'm going to put it like this, negative. is negative. So if the derivative is negative, your function is decreasing. Your function is decreasing from negative infinity to 0. Okay? You know, we did it like a table. I'm not going, you can do that as a table if you want. And how about if you pick up any point between 0 and 3? Look, what do you think? Is it positive or negative? If you plug any number, like 1, if you plug 1 for your x, you get it.
It'll be negative.
It's again negative. Clear? The 0 is what? Yes.
You can only plug in 1 and 2 there, right? You can't plug in 0 or 3.
You can plug 0, but it's 0. The derivative is 0 at that point.
Yeah.
So it
Well,
doesn't
if
give you.
you were to plug in 3.
Same. If you plug 3, it gives you 0. You need to plug something more than or less than to figure out what's going on in between. Right? At 3, of course, you have minimum, maximum, or inflection point. You know this situation. You understand it as a what? Minimum, maximum, or inflection point x when x equals 0. Anybody? X equals 0, what you have? It's like decreasing and again decreasing. Agree? So it's an inflection point. It's not a maximum or minimum. Is that clear? So if it is a maximum, you have minus plus. Sorry, if you have minus plus, it's a minimum. If you have plus minus, it's a maximum. Okay? This is like the same sign. Same sign means it's decreasing less than 0 for x less than 0 and also for x greater than 0. So it's like decrease in all ways. This is really a concavity change. We will see that later. Okay? So what about if you pick anything greater than 3? Positive, of course. If you put 4 for an example, or 3.1, you get positive. So this is increasing situation. Can anybody tell me what we have when x equals 3? At x equals 3, do we have a maximum or minimum? Decreasing, increasing. It's a minimum. Because you see, it's a decreasing because less than 3 is decreasing and start to increase at 3. Clear? It's a minimum. So you can write it here like minimum. Min at 3, at 3 here. This is like an inflection point. You can draw it like this if you want. Is that clear, my explanation here, right? So you understand where the function increasing and decreasing using the first derivative. The increasing decreasing tells you this type of extreme. Okay? Minimum, maximum, or inflection point. I know there's no maximum in this graph. Okay? But we have a minimum at 3. So that's the first one. So we found the interval where the function increasing and decreasing. So we can I can ask now, like part B, find where the graph concave up and concave down. Graph of f is concave up and concave down. Okay? Right. So I need to get the second derivative now to discuss concave up and down. Okay? Can you tell me the second derivative of the function? I got the first derivative, yes. 12 cube, so 12x square
minus 24x.
Yeah. 12x square 24x. Similarly, you can take 12x out because it's common. And I know the important point is 0 and 2. Remember, the important point here is 0 and 3. At those points, you may change the sign of the derivative, first derivative. Similarly, the second derivative, plus minus change at 0 and 2. Okay, so I'm going to do that. So this is my 0, x equals 0, and this is my x equal 2. At these points, concavity change. Concavity change means it's changed from concave up to down or down to up. Okay? Those are the inflection point. I know already there's an inflection point at 0. I know already using the first derivative even. But I didn't know what happened at 2. For example, if you don't take the second derivative, you miss that behavior. Clear? Because in the first derivative, I didn't detect what happened at 2. Because at 2, nothing happened to my first derivative. Clear? So you have to take the second derivative to get the, perfect graph. If you just take the first derivative, you may miss what happened at 2. Alright, tell me what happened less than 0. If you put like -1, this is negative, this is negative. Can you see my second derivative is positive? Here I talk about first derivative. Now I am talking about the sign of the second derivative. Clear? At 0, second derivative is 0. Anybody tell me what happened in between? Yeah, if you plug like 1, you get plus times minus. Okay. What happens if you put greater than 2? Like 3, 4, you get positive. Okay? Because if you plug 3 here, it's like 1 times 36. So if you have plus, your original graph concave up. This is concave down. This is concave up. I put, concave, C for concave, okay? Can I go back and some of you just joined. So we are going to sketch the graph of fourth order polynomial. First, I take the derivative to identify extrema. I take the first derivative and I factored, because factorized form gives me, easiest way to discuss the sign of the derivative. Okay, so I know at 0 and 3 I have my first derivative 0. I look at what happened around the neighborhood of 0. Like neighborhood by what I mean is less than 0, greater than 0, less than 3, greater than 3. And I identify the sign change, and I know it's not change the sign at 0, which is like decreasing and decreasing again. So this is one of the inflection point I can even detect from the second derivative. And at 3 we have a minimum, because less than 3 I got negative for my first derivative, which means my original function is decreasing. Greater than 3, my original function is increasing because the first derivative positive. Good. And when I come to second derivative, I understand at 0 and 2 I have inflection point. 2 is like a new inflection point, which is we did not find over there. Okay. So now I know almost all the information. Maybe, so what else? Okay, so I can summarize. Okay, this is what I want to really share with you. How to summarize the board. Okay, summarize or summarizing the information we already have. Information from A and B. This is what I did. So I have 0, 3 and 2. Those are the all important points. So I can mark them like this. This is 0. Oops, I want to mark it here. 0. This is like 2, 3. First derivative gives me 0, 3. Second derivative gives me 0 and 2. I include all those, and I'm talking about what happened less than 0. So I know it's decreasing and concave up. Less than 0 decreasing and concave up. In between 0 and 2, concave down. The graph look like this. And in between 0 and 2, I know it's decreasing. In between 2 and 3, concave up. Okay, concave up. 2 and 3 is still decreasing. Greater than 3, increasing. And greater than 3 here, still concave up. Okay. Clear? Now you have all the information to draw the graph. Okay. Any questions? So when I draw it, I think this is enough to draw. Okay. This is my x. This is my fx. So I can quickly look at my y-intercept, because if you put x0, you get 10, right? That is your y-intercept. I can mark it here. What happened? Less than 0, decreasing, and concave up. So it's going like this. So concave up means like a U shape, but it's decreasing. In between 0 and 2, decreasing is still, concave down. The concavity change at 0, I know, because that's one of the point, the second derivative is 0. So this is 0, and I'm going to mark 1, 2, maybe 2 here, 3 here. Okay. Something like this. At 2, you can plug 2 here and find out what it is exactly if you want. For an example, f of 2 is what? 16. This is 8 times 4, which is 32 plus 10. So it will be negative 6, right? Can I double check? Yeah, 8 times 4, yeah, it's negative number. Negative 6. So that means this really coming down. I can draw it like this. Yeah, it's negative 6. Yeah, I'll draw it. Coming like this, and at 2 is change, because 2 is one of the inflection points. Concave down and change it to concave up at 2. Okay? This number is negative 6. That's what we got. Okay. And I have minimum at 3. So 3 is somewhere here. I get the minimum. Okay. And it's going like this. Because greater than 3, it's concave up again. Actually, greater than 2 always concave up. So you can see from here, concave up. From here to infinity, concave up. So I wanna clearly draw this. This is like concave down, and concave up. Is it clear? Everything? Okay. Concave down, concave up, concave down, and concave up. Clear? Look, is that clear? You can say decreasing up to 2, up to 2, yeah, you can see decreasing up to 3, yeah, to 3, and increasing after that. Clear? Just question?
So over at part C, I'm confused why, like the down arrows, it's kind of like why the curves like not all. Like
This, you know, greater than 2, right? Greater than 2, always concave up. That's why I draw the same thing here.
Is that just for like every time it's more than 2?
Yes, that's true for more than 2. But, you know, in between 2 and 3, it's decreasing. You see, you know, if you think about this one, you know, greater than, you know, let me go with that, okay? 2, you see, greater than 2, it's always concave up. Can you see that? Okay, greater than 2, it's concave up, but 2 to 3, decreasing. 3 to infinity, it's increasing. So that's why I draw it like, I could, you know, I can consider just draw it like a 1 concave up if I want, right? But I want to tell you, you know, even though this is concave up, it's like from here to here, it's like 2 to 3, okay? Yes. This is like my like a turning point, the minimum, which happened at 3. Clear? Any other questions? First you take the first derivative, find out where the increasing decreasing changes, and second derivative tells you where the concavity change. That's all.